Hello, and welcome to Oracle Solaris 11 ZFS lab. In this lab, we are going to explore some basic ZFS commands and features, like managing ZFS pools and file systems, using compression and deduplication for ZFS file systems. Let's start with exercise Z1. It's called ZFS pools. Imagine you have several disks and you want to add them to your system. To do that in ZFS, we have to create a special ZFS disk pool. Let's start with working with pools. First command will be zpool list to figure out what we've already got in our system. As you can see, we have one ZFS pool called rpool, which is our root pool. In Solaris 11, your root file system has to be ZFS file system, and that's why we have this root ZFS pool. What do we know about this pool? Let's call status, and we see that its state is online and we don't have any data errors, and this pool uses one disk C7D0. Okay, let's create our own ZFS pool. Before doing that, we need several disks. In your real-life system, obviously you will use your disk drives. In our VirtualBox system, we will create several files which will act as disks for our ZFS pool. Let's do that. We go to dev.dsk folder, and then we do makefile, and the size will be 200 megabytes, and we call them disk from 0 to 9. It will take a while. Okay, now we have 10 disks or files to use as disks, and we are going to create our first ZFS pool. We will call it lab pool. zpool create lab pool, and we are going to use protection level called RAID Z, and we are going to use disk 0, disk 1, disk 2, and disk 3. That was fast. Okay, now let's take a look. Again, zpool list, and now we have our lab pool, and we have its size, we have deduplication ratio, and all that. And by the way, if you take a look, our ZFS file system was already created. By default, it is mounted at /labpool, but obviously you can change that. Okay, what if we want to add some disks to this pool and to this file system? That's easy too. Add to lab pool, and again we're going to use RAID Z, and disks from 4 to 7. And again, it was fast, and you can check. zpool list, and you see the size of your lab pool was increased, and then the size of your file system was increased as well. So, but this is the basic ZFS operation of creating ZFS pool and ZFS file systems. In our next exercise, we will explore ZFS compression feature. So we will create a ZFS file system and we will set compression to on, and then we will try to copy a bunch of files into that directory. And we will see how much space we can save by using ZFS compression. Okay, let's create this file system to store a part of our system manuals. And we will use our ZFS pool, which we have created in our previous exercise. We will set compression to gzip for this file system. And obviously, as with normal gzip command, you can use different options to make it more dense or faster. And now let's copy our files into this ZFS compressed file system. And let's compare the sizes. You see, we just saved more than half of our disk space by using ZFS compression. In this exercise, we will explore another method to save storage space using ZFS. It is called ZFS deduplication. Imagine your users store their archive files in the special archive directory. And most likely they have a lot of similar files, and those files have a lot of similar blocks. That's how we can save space using ZFS deduplication. Let's create a separate file system called archive on the same lab pool, ZFS pool. And we will turn deduplication on. And just in case, we will turn compression on as well. Okay, and then we will create 4 separate file systems. Imagine those file systems are for 4 separate users, and we will call them A, B, C, and D just for simplicity. And now we will create an archive file, and then we will copy this archive file 4 times into 4 separate file systems, and we will see what happens. Let's see how big is this file. Okay, about 3 megs. And then let's copy this file to our archive directories, archive file systems. And now let's check the status of our ZFS lab pool. deduplication ratio is 1 because we copied only one file. Now let's repeat this operation for file system B and check deduplication ratio again. It takes some time for ZFS to figure out that files and blocks are duplicated. And now you see that deduplication ratio is 2. And now we repeat this operation for file system C. And again, we check deduplication ratio. And now it's 3. And the same for the D file system. And now deduplication ratio is 4. It's interesting to check our compress ratio. And you can see that compression didn't help here because obviously we copied our archive file which was already compressed. And this is kind of homework for you to figure out which way of saving storage space is better for each particular data set. In this exercise, we will explore ZFS snapshots. First of all, let's take a snapshot of our archive file system. And check what we have here. You see, we have created a snapshot of our archive file system, and because of the option -R, we have created snapshots of all children of this archive file system. Means file systems A, B, C, and D. Now imagine that our user A, which stores your archives in your archive/A file system, just deleted all her files. So what she used to have before. And now imagine she had accidentally deleted all your files. Nothing there. What we can do? Obviously, we can go to tape archive and mount our tape and restore from backup, but it's better to use ZFS rollback. And now, everything is back. That was easy, that was fast, and what's most important, ZFS snapshots don't take a lot of space. Basically, they don't take any space at all before we started changing something in our main file system. In this last ZFS exercise, we're going to talk about ZFS clones. Imagine our user A wants to keep your archive files in our lab pool/archive/A file system, but at the same time she wants to work with that archive. She wants to unpack and change some files. To do that, let's create a clone of that archive file system. You see, we cannot create a clone from a live file system, but we can create a clone from a snapshot. Let's take a look. You see that our clone file system takes very little space like only about 27 kilobytes. And it will not grow until we change something in this clone file system. So let's go to this a_work directory and change something. You see, we have this archive file, and let's try to unpack this file. You see, unpacking this file had created a user/share/man directory and unpacked all our manuals in that file system. Let's check if it's still available as a file in our original archive file system. You see, the file is there, but it was not unpacked. Now, after this short overview of ZFS commands and features, you know enough to start doing your hands-on lab on ZFS file systems and pools. Good luck!